Hello everyone, welcome back to another episode of our Django eFarm project tutorial series, and in today's session we have some exciting updates to our cow model. I hope you've been following along with our previous tutorials where we've covered various aspects of our daily app. And as always, if you are new here, don't forget to hit that subscribe button and ring that notification bell so that you won't miss any future updates. And now, let's dive right into the latest changes that we've made to our cow model. As you can see on your screen, we have our trusty cow model class, and I'll walk you through the newly introduced fields. These new fields are essential to enhance the functionality of our daily app. The isBought field is a Boolean flag that tells us whether a cow was bought or raised on the farm, and this way we can keep track of the cow's origin and manage our inventory accordingly. The category field represents the current status of the cow, and it shall have several choices such as the calf, the heifer, the bull, and some others. Categorizing our cows allows us to organize them based on their developmental stages and manage their care appropriately. And then last but not least, the current production status field is crucial for our dairy farms as it helps us to track the cow's current production state such as the milking, dry, pregnant, and some others. So this information is invaluable for optimizing milk production and our herd management. And with these new additions, our cow model is even more robust and ready to handle the complexities of a real-world dairy farm. Alright, now that we've introduced the new fields, let's switch over to our code editor, PyCharm, to see how they're integrated into our cow model. And here I have our cow model open and ready for us to explore. You can see over here we have the three new fields. The isBought field is a Boolean field that's actually defaulted to false, so we shall assume that for each and every new cow data entry, it's actually born in our farm, but we can as well make it true. Then we also have the current production status over here that shall be a choice field from the cow production status choices, as well as the category that shall also be a choice field from the cow category choices. And scrolling down further, we have some new stuff over here. That is the concept of the Django managers, the things that you're seeing over here. So before we proceed to the managers.py file, let me introduce you to the Django managers. In Django, managers are objects that handle querying and retrieval of the model data. They are like assistants to our models, providing a convenient way to retrieve the specific data from the database. And now in our cow model, we have two managers defined, the two over here. The default objects manager, this one over here, and the custom manager called the cow manager. So the objects manager is Django's default, but we also created a custom manager to add some specialized functionalities. And with this custom manager, we can write custom methods to perform complex queries or validation specific to our cow model, as you will see. And now that you understand the concept of Django managers, let's dive into the managers.py over here and explore our cow manager into details. And as you can see, we have several methods here that provides us with valuable insights that enables us to perform complex queries effortlessly. So I'll quickly run through the methods and give you a brief explanation for each. So starting with the very first method over here, the getTagNumber actually generates and returns a unique tag number for our cow. So this is how it works. We retrieve the year of birth of that cow from its date of birth. Then we also retrieve an uppercase of the first two letters of the breed name, as well as the unique ID for each and every cow entry in our database. This is provided by Django by default. And then we return something like, for example, if a Frisian cow that is born this year is saved in our farm as the very first cow, we shall have the FR capital hyphen 2023 as the time that I'm recording this, then -1 because it's the first cow in our database. Then we also have the calculate age method that actually calculates and returns the age of cows in days. How it works is that it takes the date of birth of that cow and subtracts it from the today's date and returns that age in days. So the calculate age in farm just operates on a similar principle as the calculate age. The only difference that here it now uses the date introduced in farm in the field. By the way, if a cow is just born in the farm, literally the calculate age and also the calculate age in farm shall be the same thing. Then we also have another interesting method over here, the get calf records. So this one shall actually returns a list of calf records associated with the cow, where if this cow is actually a female, then it will go ahead and then filter all the cows that have this cow as their mother, or rather the dam. And if it's a male, then of course the father, which is a sire. And then since the calf records is actually a query set object, because filter actually always returns query set objects, and that's a complex data type, we shall actually use the list method to convert it back to the Python native list so that we can work with the calf record easily. And just like that, now we have the calculate parity, which shall actually return the number of times a female cow has successfully given birth. So of course, if the cow is a female, then we shall go ahead and then now check the length of the calf records. And because the calf record is a list, now we can apply the length method to retrieve the number of objects, or rather the number of cows in the calf records. And so that will be the return value for our calculate parity. And then we have the get available cows, pregnant cows, male cows, the get female cows, get sold cows, get dead cows. So these are quite simple. You can see all they just do is just return a query set of the available cows, or maybe pregnant cows, as well as the others. You can see what it simply does is that just goes ahead and then, for example, for this, we filter the cows based on the availability status of alive. And so with these powerful methods, our cow manager provides us with a streamlined way to fetch specific data from the database and handle various operations related to our cows. And now that you've got a glimpse of our custom cow manager, let's head over back to our models.py. So scrolling further down, we have our clean method and also the save method overridden. And remember, from the previous tutorial, I had introduced this concept of chunking these validations into a single file, that is the validators.py. So without further ado, just head over to the validators.py. You can see we have several methods for validating our cow. So there's the validate uniqueness, validate the cow's age, validate the pregnancy status for the dead cow, validate introduction date, validate age category. So quickly run through to tell you whatever is happening inside here. So this validate uniqueness actually performs its validations on the cow's name, where the cow's name has to be either 3 characters or more. If there is some sort of number that is applied in between the name, then we shall throw this error. And also we ensure that there are no duplicates for that very specific name of that cow in our database. We also validate the age of the cow, where we ensure that no cow is older than 7 years. Hopefully this makes sense even to you. Cows who are above 7 years are typically economically not viable. I mean, these cows have very low milk production and stuff of that kind. We also ensure that the date of birth that is provided is not in the future. So we also perform the date of death validation, that is based on the availability status as well as the date of death field. So what really happens over here is that if the date of death is changed to become dead, technically meaning that the cow is now flagged as dead, then we have to provide the date of death. We also ensure that the date of death that is provided is not in future, and then we ensure that the date of death entry is not longer than 24 hours. I hope you understand the rationale here. So what really happens is that there is no way a cow can die in a farm and then within 24 hours, either the worker or maybe the farm manager or just the farm owner doesn't realize that there's one cow that is actually missing. So these are the several methods, but I'll not go through them because there are so many, and just in the interest of time, you can see there are so many. We have even the validate introduction date. That is actually redundant for now because the date introduced in the farm is something that is being populated here by default by Django. So you can see it's an auto now add true. So I've added it here because sometimes you might mistakenly remove the auto now add true and you will lose that validation. So this keeps you in check. Then we have the validate production status over here. Yeah, so because this is quite complex, I'll go through it, and you can see it has a plethora of parameters. There's the production status, gender, the category, the age, the calf records, as well as the isbot field. So quickly running through it over here, first of all, I just collapse this documentation over here. So we check if the production status that is availed is a valid cow production status choices. If not, shall have that error. And we check if the cow is a male and it's less than 3 months old, it has to be flagged as a calf. If it's now between 3 months to 6 months old, it has to be a winner. So the reason why I've placed it 3 to 6 is that different farmers have different winning regimes. Some maybe 4, some 5, some 3, and some even up to 6. So that's the reason why I place it this way. And then now, if the male cow is between 6 months old to 1 year, remember, by the way, our age is being calculated based on days. So I've just been doing the conversion into months. So what really happens over here is that if the cow is 6 months to 1 year old, it has to be classified as a young bull. Remember, we are inside the gender that is the male cow. And if that cow is 1 year to maybe 2 years old, we give it a bull status. If not, we shall have that error. And if the bull is older than 2 years old, of course 365 times 2 is 730. So if the cow is more than 2 years old, we have to classify that cow as a mature bull. So then we have the else statement over here that is actually for the female cows, where just like the male, if the cow is less than 3 months old, it has to be classified as a calf. Between 3 months old to 6 months old, it has to be classified as a weaner. And then between 6 months old to 1 year old, it has to be classified as a young heifer. And if the female cow is older than 1 year, then there are several stuff that now we are considering over here. First of all, if the cow is categorized as an heifer, of course, sometimes a cow can be 1 year old and it has not given birth, so it's technically a heifer and it was bought. Then we have to ensure that the cow production status must be either open or pregnant and not lactating. If that's actually violated, then we shall have this error over here. Both heifers should only have the open, pregnant, not lactating as their production status. And then if the cow was not bought, so technically the cow is a heifer which was actually born in our farm, it has to have this production status with additional one, that is the culled. Of course, it makes sense that there's no way a cow can be bought, then at the same time it's culled. Maybe it will be culled later. And then now we also verify if the female cow is categorized as a milking cow and it's actually bought. So this is a case where maybe a farmer has bought a cow that has actually given birth to a certain calf wherever it was before it was brought into our farm. So the production status must be either open, pregnant and lactating, or dry. And if the cow was born in our farm, meaning that it was not bought and it has some calf records associated with it, so the any method over here returns true or false based on availability of data in our list, where if the list has 0 items in it, it shall return false, or if the list has maybe single item, that is a single calf record associated with that cow, then it shall turn true. So if that's the case, then the production status must be open, dry, pregnant and lactating, as well as culled. And if that's not the case, we shall raise this error. Female cows categorized as milking cow over 1 year old must be associated with some calf records. And so that's it for our validators.py. Let's head over to the serializers. And you can see our cow serializer has a couple of updates. First of all, the breed field is now being serialized by the cow breed serializer over here. So that technically shall bring the nested serializer problem, but hold on, we shall actually handle that. So in the create method of our serializer, this is actually overridden from the default create method that this serializer provides. We first of all pop out the breed and then check if that breed's name is actually existent in our database, and if it doesn't, we shall go ahead and create that breed and then now create that cow with the breed that's actually created or retrieved from the database. And so this is quite important because we shall be able to actually send a new cow with the new breed's data by a single request. And then for the update method of this serializer, we pop out stuff like the breed, the gender, the sire, the dam, the eastboard, as well as the date introduced in the farm. So the rationale over here is that there is no any way that, let's take for example a breed, there's no way that a Frisian cow can become a Jersey cow. So that was the rationale that actually fueled the overriding of this update method. Then now the rest of other fields, that is the name, the date of birth, the category, the current production status, as well as the date of death, all these now shall be updated based on whatever request or whatever data is changed. So we then save the instance and then return that. And that's now a quick overview of our serializers. So we shall move over to the permissions.py. And over here, these are very simple, I think, from the previous tutorial. If you actually followed over there, you will quickly understand this. So we have this permission of they can add cow, can update cow, can delete cow, as well as they can view cow. So quickly going through them, we'll only allow the farm owners and the farm managers to actually be able to add cow. So first of all, by the way, they have to be authenticated. So basically, if you apply that anywhere, only users who are flagged as owners and the managers shall be able to perform that action. And then in order to update the cow's details, we shall As well, we only allow the farm owner and the farm manager. Then for the deletion of a cow from the database, it's only the farm owner who can do that. And then now for the viewing, all the farm staff can do that, where the farm owner, farm worker, the farm manager, as well as the assistant farm manager can actually view the cow records in our database. And that was a quick overview of whatever we have in our permissions.py. So we head over to the views.py over here, where we also overridden a lot of stuff in our CowViewset and added some as well. So you can see that we've added the filter set class and also the ordering. So we shall be able to order our cows based on their date of birth, the name, the gender, the breed, as well as also perform filtration based on the fields, as I will show you in the cow filter set. So in this view set, we only allow that the cows, or rather, we actually employ the permissions that I've just talked about. For the create, it's only the farm owners and the managers who can do that. This is only for the farm owners. Then for the update, it's also the farm managers and the owners. And then in order to view or retrieve the cows from our database, all the farm staff can do that. And so before I proceed to the list method, so I'll just quickly go ahead and show you whatever the cow filter set actually entails. And that's actually provided in our filters.py. So here's the cow filter set, and it has several fields. So we shall be able to filter based on the cow breed, the ISBO, the year of birth, the month of birth, the week of birth, day of birth, the availability status, the tag number, as well as the name. So from the previous tutorials, I think this is the only concept that I've not spoken about, where you can see we have the year of birth. So you might be wondering, but Peter, there is no any year of birth as field in our cow model. So this is how it works. The underscore actually acts on the date of birth to retrieve the year. So it's basically like a lookup method for the year in the date fields, and the month as well operates on the same principle, the week, the day. And so that's it for the brief tutorial of whatever we have in our cow filter set. So now that you know the options that we shall be performing filtration based on all these fields over here, so let's head over back to our views.py, where we are now overriding the default list method over here in order to effect the filtration if it's actually supplied with the request object. So over here, we check if the query set does not exist. So typically, if the query set is empty over here, because the request query parameters does not return anything, we shall throw a HTTP status 404 with the detail no cows records found matching the provided filters. Or if the request query parameters are not there, this is like the case of just a plain request where we want to retrieve something, but typically we do not have any cows data that is populated in our database. So we shall throw no cows record found in the farm yet with a HTTP status 200 OK. And if the query set has some stuff in it, we shall serialize it and then return a response serializer with the status HTTP 200 OK. And that's it for our views. Finally, we shall go ahead and do the testing over here. From the previous tutorial, we've actually now refactored how we store our test, where now we have this folder of the daily app. So inside our daily app, inside the test folder, let me expand this a little bit. So let's talk of the test views in the interest of time. So we shall be testing the view set, that is the cow view set. So first of all, since we had permissions that requires authorization, so we avail all these logged in users with their token, username, or even maybe the ID. So the first method over here, we're testing the add cow as a farm owner. Of course, this should allow. So we construct the URL over here and then also the headers, and then now send a post request with the request payload to be the general cow data. So that is something that I added in this tutorial. So let me show you that in the conf.test.py. So this method over here is actually a fixer that shall be supplying a dictionary of cows data. Over here you can see we have the name, the breed, the date of birth, the gender, and stuff of that kind. So back to our test views over here, that's what's happening over here. And by the way, to avoid any errors, we have to specify the format, and in this case we shall be using the JSON. Let me take you back over here. You can see we have a nested problem over here. So it's only JSON that actually works best with this. And then we also supplies the authorization headers and check if the status code is actually to 1, meaning that that cow is created, as well as also check if the name of that cow exists. So there are these other very many methods over here. So I'll just quickly go over this as well. The test update cow detail as an assistant farm manager permission denied. Of course, updating we only restricted to farm owners and the farm managers. And now over here, we create a new cow this way in order to avoid the intricacies of literally creating a new breed. First of all, that is, if we were to use the default cow.objects.create, we had first of all to create the breed and then now assign that breed in the field of the breed for the cow. So actually, by using the cow serializers, everything shall be handled for us as we had actually defined in our create method over here. You can see it will go ahead and then pop that breed and then does its stuff over there. And so after we create that cow, then we also now avail the update data, that is the name of the updated cow, and then try sending that request with the token for the assistant farm manager. Of course, the response status code has to be the HTTP status for 3 forbidden, and we also ensure that the name of that cow is actually not changed. And so that's it for the quick overview of the test. So we shall go ahead and run them. Over here, first of all, we check the folder where we are in. Okay, and now we run the PyTest. Okay, this test will take a little bit of time, so I'll just fast forward this into completion. Alright, in 72 seconds, we have 71 tests passed. So these tests are so many like this because remember from the previous tutorials, we also have tests to do with the user's app as well as the cow breed, and also today we also have some more. So if you find my tutorial helpful, please consider subscribing, liking and sharing, and any question, don't hesitate to comment. See you in the next one, and bye bye.